if we talk in terms of the classification of rotating machines with respect to supply system, so it can be classified into two. If the supply is AC, then it is AC machines. If the supply is DC, then it is DC machine. Okay. And they are further classified in two parts based on the operation. Okay. So these classification is motor and generator. So either it is AC motor and AC generator, and DC motor or DC generator. So we will study on these grounds. Okay. So and what is the difference between them? What is the difference between the motor and generator? What are its types? What are its applications? And as far as DC go, we will study its need, motor, generator, both its classification, its types, and its working principle, EMF equation. Okay, so we will be focusing on these things first. Okay, so we got to know that what is the need of the DC generator. Okay, so we have seen that the although we get the DC supply from the batteries, okay, these batteries can be used in inverters, UPS, mobile batteries, etc. But the main problem of these batteries are that it is less in magnitude. Okay, so if we are required to have the large magnitude of the power, we require DC generator. Okay, and what is the advantage of this DC batteries? That these are portable in nature, and also it is the one of the advantage over AC machines and AC generator and AC supply also, because DC can be stored, DC batteries can be stored and purchased at will. In case of DC batteries, if the battery is off, whether it is wall clock battery goes off, it is weak, it is need to be replaced, we can go to the market and purchase accordingly, we can save accordingly. So, and also there are specific applications which can be done only in DC supply. So there also the DC is used. These applications are electroplating, electrolysis, etc. Okay, so these DC can also be used for constant speed applications, as in the case of the DC shunt motor. So in general, we can say that in generator, what does it happens? That the mechanical energy is converted into electrical energy, and in DC motor or even in AC motor, what happens? The electrical energy is converted into mechanical energy, because we are having the motors at our home. Fan motor is there, water tulu pump motor is there. What happens? We switch on the electric supply and it rotates, and submersible pump is there, and what it does, suction is created and water is pumped in the top rooftop. Okay, where we may be having the storage tank. Okay, so what is done? Mechanical work done is being performed, or electrical energy is converted into mechanical energy. Okay, but in the generator, reverse happens. For example, in marriages, you must have noticed DC generators are used, DG set are being used. We walk into the streets of the streets in the marriages, keep on dancing to the tunes of those bands. Okay, so but the electric supply, whether it is the light or that loudspeaker which is with those musical bands, that is operated on DC generator. Okay, so now suppose that this is the diagram of the DC generator. Okay, so it is having north pole and south pole as a, and it is constituting a magnetic field. So, and the portion which is within these poles is rotor. Okay, which is the rotating part. This is north pole and south poles, and this magnetic field or the magnet system can be of three types. First is the separately excited machines are there, in which the electric supply, we have to initiate the generator first or take it to the excitation level, starting level. So what needs to be done? The DC supply is required. Okay. So either the DC supply can be given externally via any battery system. Okay. Or second is part is the permanent magnet based. If the field system is very strong and the magnet system is permanent magnet, then this is also one of the classification. And third is the self-excited DC machines. Suppose that we are having a three-phase AC supply. One electronic rectifier is placed here within the lab. Okay. So what do we understand by the rectifier? It converts AC into DC in this simple language. Okay. And we have studied the diodes in our lower classes. Okay. The diode converts AC into DC. Silicon controlled rectifier or SCR. Now this AC into DC is converted, but output voltage can be regulated or controlled. What we do, we connect this DC supply in this magnets. Okay, so the field magnets are there. So field coils are there. Okay, so you know that the current carrying conductor produces a magnetic field, or when the current is being supplied to the electric field, what happens? The magnetic field get energized. Okay, so when it energizes, what happens? Now these field coils, this is armature, that is the rotor part, and it is having the armature slots, and in those slots armature coil is there or copper winding is there. So now what happens? These field windings is connected to these armature windings. Okay, these can be connected in series or in parallel. In construction wise, DC machines, both DC motor and generator are same. Okay, principle is different, application difference, that is there, but the construction remains same. Okay, so these are connected to armature coils in series or parallel. So when they are connected in series, then that machine is called series motor or series generator. And similarly, if they are connected in parallel, then they are called shunt motor or shunt generator. Okay, and also there is a third combination in which the field windings are partially connected in series and partially connected in parallel. So at present you should focus that the field winding is connected to the armature winding, and this field winding is supplied by the rectifier. So it energizes. So when it energizes, magnetic field is developed, and when magnetic field is developed, it means that the flux is passing through north pole to south pole. Okay, and due to this rotor, which is the rotating part, suppose it is in clockwise or anti-clockwise, whatever it may be. So what it does, flux cutting is there. So whenever flux is cutting, d phi by dt is there, and it means that the EMF is produced. Okay, so this is basic working principle or physical working principle of DC generator. Okay, so generator, what it does, it converts mechanical energy into electrical energy. So mechanical energy is to be supplied so that it can convert into electrical energy. So how this mechanical energy is supplied? So, and where it is supplied to the rotor. Okay, so when it is supplied to the rotor, what happens, that the rotor rotates, and when the rotor rotates, then the EMF is generated due to the cutting of flux. Rotation is to be induced. Okay, so how it is done? So either it can be done manually, okay, as in the initializing state, or in the DG set, when the DG is started, you must have seen that the person who is operating, he winds a thread over the rotor and give few rotations, and it pulls suddenly to give some initial starting torque to it, and then it is connected to turbine, and turbine is diesel engine, and that diesel engine is connected to this DG set or generator set, and it gives the electricity. And the second process of giving the rotation is to operate the MG set. So what is this MG set? This is motor generator set. M for motor, G for generator. So what motor is doing? Motor takes the electricity supply and rotates. So when this motor is coupled with generator, okay, suppose this is our motor and it is mechanically coupled with the generator, okay, and since this is motor, so some electricity supply, starting level supply is given, so it starts rotating. Say it is rotating in the clockwise direction, so the generator is coupled, mechanically coupled with the help of the shaft. So generator, this is motor, this is generator, so generator will also start rotating in the same direction and the same speed. Okay, so this is also another method of giving the initial speed or rotation or mechanical energy to the generator. Okay, now let us suppose that this speed is imparted, and the force which is responsible for this is F, and it is LHS to RHS as shown. And suppose that the distance which it will cover is D. Okay, D distance, or you can say D diameter as well, if it is traveling from LHS to RHS. Okay, so distance traveled will be D, and say time taken is T. So the velocity which is imparted is V is equal to D by T. Due to the application of force, the velocity which is experienced by this rotor or rotating armature is d by t. Okay, and Also, suppose that this length of the armature, this is L. Consider this conductor of length L meter which is placed in this and average flux density is B Tesla, and it is uniform. It is provided by two magnetic poles, North Pole and South Pole, and direction of the magnetic field is from North Pole to South Pole, which means that the flux is passing from the North Pole to the South Pole. Okay, and force F is applied from left to right with velocity of V meter per second in a direction perpendicular to magnetic field. Okay, so due to this force, the conductor moves from A to D, covering the distance of D in time t seconds. Okay, so now what does Fleming's right hand rule signifies? We have to see that to it. Okay, what we have seen there, if we are applying Fleming's right hand rule to consider the working of the generator, the direction of the application of force, if it is LHS to RHS, and if the magnetic field is from up to down, then the current goes inwards. Okay, so how do we represent the inward current? So inward current is denoted by cross. Okay, as you can see that you are having the screws at home or at walls. So what happens, the top of the screw or the head of the screw is having cross. So when that screw is nailed inside the walls, what we can see, we can see only the cross which is at the head. Same thing happens here. And if we reverse that screw, then what happens? Then we can see only the tip of that screw. Okay, so that is dot representation, this is cross representation. So this is the difference between, and it is important to remember this. Okay, so this is how we can understand the working of DC machine. So EMF E is produced. So if T is the number of turns in the coil and d phi is the change in flux and dt is the time taken to change in flux, then the formula what we remember generally is the minus n d phi by dt. So if the t is the number of turns, so it is minus t d phi by dt. So if t is 1, then it can be ignored. And the flux, the formula of flux is ba. So B is the flux density, A is the area, and area we have studied as L into D. Okay. So if T is the time taken, then this EMF formula becomes E is equal to minus BLD upon T, and D by T is velocity. So the EMF becomes minus BLV. Okay, so this is applicable when the conductor moves at 90 degrees with respect to field, as we have shown in the Fleming's right hand rule. But if it is moving at any angle theta, then it becomes minus BLV sine theta.